All right, so we want to talk about identifying the L wave when we're using FAST to look at an ID-connected flaw. And one way to do that, we talked about this earlier, is to find the flaw and pull back on it. The last signal up should be the L wave. Another way to verify if you're pretty sure you have an ID-connected flaw is to do surface distance plotting. And that would work something like this. Let's see if we can get this to stay. Let's say we have an ID connected flaw here, and we're looking at it with a fast transducer. It's a high angle, and high angle 70 degree, but there's quite a bit of beam spread, so there's a spread of angles there. And when you have an ID connected flaw like that, you could hit that with many different angles. You could walk that to any depth you want, pretty much. So, but what you want to do is walk that to where you're catching it at, say if your material was 300 thick, walk that to where it's right at 300 deep. At that point, that's when you're hitting it with 70 degree. And that's what the trig is in your instrument. It's calculating for 70 degrees. So this is where you get your most precise measurements. So walk until it's at the thickness of your material, at the ID. And then you can take a surface distance measurement from the front of the transducer. That would be your surface distance minus X value reading box. And you can do that from both sides. When you do that from both sides, those two plots, if it's an ID connected crack or notch type flaw, planar flaw, they should plot up to the same point like this on the surface. If you do those surface distance plots and they plot past each other, or they don't reach each other, then you should go back and refigure out what you're looking at. Maybe you don't actually have the 70 degree L wave. Maybe you have some other mode of sound. Let's try that on the block. All right, so I've got my my FAST Model 1 probe hooked up, and I've already recalled the cal, checked the cal, set the gain, and I'm ready to go. I'll go ahead and set reference TB. Boom. And so we're going to be working with our reading boxes here. We're going to find one of these ID connected flaws, walk it to the depth equal to the thickness of the part, and then check the surface distance with the surface distance minus X value reading box. So we could use any of these. Let's try the 10, 30, 60. Let's try the 60 thou. The last signal up as you pull way back is the L wave. That's the one we want. So walk it to the ID at 300 deep. Now I've walked it to where it's 300 deep, and the machine is calculating for 70 degree. So I'm probably hitting the corner pretty much exactly with the 70 degrees. So that should give me my most accurate measurement for the surface distance minus X value. And that's saying 533. I hope you can see this on the video. There's the notch, the surface distance minus X value, and that does look like 533. So if I was in the field and doing this on a crack, I would take my pencil and mark exactly where that point is on the surface. Then I would come around to the other side and repeat from the other direction. As I pull back, the last signal up is the L wave. Let's walk that to the ID at 300 deep. There, that'll give me my most accurate measurement for surface distance minus X value, 532. Hope you can see that on the video. There's the notch. Let's look at the surface distance minus X value, 533. Looks pretty precise. And then ordinarily I would come and that should line up with the previous pencil mark. All right, thanks a lot.